right, in this video, we are going to look at problem number 30 of our benchmark from our midterm, one of the more missed questions on the benchmark. So our question says the function g equals x plus 4 squared minus 3 is restricted to the domain -infinity to -4. Which graph represents the inverse function of g of x? So we have a function that's restricted and we want to find its inverse. So let's not deal with the domain restriction quite yet. Let's actually find the inverse of this function because we're looking at graphs here. They want to know which graph is the inverse of the function they gave us as an equation. So we're going to use Desmos to help us with that. So let's write down our function and follow our method for finding inverse. This is y equals x plus 4 squared minus 3. And we switch the x and the y around and then algebraically solve this, isolate y over here. So we're going to add the 3. Then we're going to take the square root of both sides, which will put the square root over here. And anytime I take the square root of something, I need to add a positive, negative sign in front of it because it could be positive or negative square root of that. This is just going to leave me as y plus 4. And then I will minus that 4 over. And I get x plus 3 minus 4 equals y. Now this is the inverse of the function. And it's actually two equations. That's why I have a plus and a minus in front of it. The only way I can represent parabolas, the whole thing, as inverse is if I get that plus or minus in there. Now this has a domain restriction with it. This is all the x's that are less than -4. So I think this is going to help to look at this in Desmos, but one thing we can gather from that is because all these x's are negative, that means I don't want positive answers to come out of this thing. I want negative answers to come out. So I actually don't need to worry about the positive side of this. So when I look at the graph, because of the domain restriction being x's are negative, it means that I want this one to only output negative answers. So that means I'm only going to need to look at the negative side of this equation, not the positive side, because square root's always going to be positive. So I have this initial function graphed, and then we can look and see what the inverse looks like and see if we can match it up from there. So our function looks like this, and I put our domain restriction in here. It's just half of the parabola. It starts down here at -4, -3. And it goes upward this way forever. Now, a couple things that we know just by looking at this graph. We know that this is going to get reflected over y equals x line. So we know that if this is going to get folded over that 45-degree line. So we know it should be something like this, and we know it's going to go downward because of the shape that we have of the function. Now, if we look back at the question and we look at the most common error here, most of us picked A when we missed this problem, which means we graphed this function with its domain restriction and just picked the function itself. We didn't finish reading the problem to see that they wanted this graph to be the inverse of this function. So we were part of the way there, we just didn't look at the inverse. I think even without having the inverse function, you can probably reason to say, well, I know that this graph is going to curve downward this way. And even more, what do we know about this point? Since it's its inverse, the point should start at -3, 4, because these things will be flipped for its inverse. So if we look here, this one starts at -3, 4, which was our correct answer. It was C. And we could see that just by typing in the function and its domain restriction here. But since we actually do have the inverse equation, let's look at what that looks like on our graph and see what we get. So this would be y equals negative. We have the square root of x plus 3 minus 4. And we see that that equation that we found actually falls in and uses all of the points we saw. We see that that endpoint got flipped from the one that we had before. We see this is -3, 4 instead of it's the flip of the coordinates from that -4, 3 we had on the function. It curves downward like we thought it should. That is our inverse. So with this one, I think the only reason we missed it is we just didn't read the question enough to get to this one word right here, inverse. We probably saw this function with the domain restriction and said which graph represents, and a lot of us stopped reading and picked the function instead of looking at its inverse. So I think with this one, it's make sure you read those questions all the way to the end.